Greetings once again and welcome to another awesome SETMind edition. In this edition we are looking at question 3 for the Engineering Maths 1B course, looking at the 2023 calculus exam. So in this question we are required to find dy dx in the simplest of form, and we are given this function here which is arctan of the hyperbolic tan of x. So there's a couple of things which I need you to remember as you look at this question, and this is around hyperbolic trig functions. So what I need you to remember is the following, which is that whenever we derive hyperbolic tan of x, the answer will always be hyperbolic sine of x. And also I want to remind you of a few trig ratios, since we can see that we have hyperbolic tan. So if you have 1 minus hyperbolic tan square of x, this becomes your hyperbolic sec square of x. So these trig ratios and others will be very important when we start dealing with this problem. Another thing that I want to remind you is chain rule. So this you should remember from when you were doing things long ago, which is that if you derive the derivative of f of g of x, the answer you get is you derive f and then you multiply by the derivative of g. So that is chain rule. So we can now go to our problem where we are given that our y equals arctan of the hyperbolic tan of x. So if we go ahead and differentiate, we'll have dy dx equaling, let's put in dy dx of all of that first. So it will be that, but one thing I need you to remember quickly before we get into it, it is that whenever you are deriving your inverse tan of x, what you get is 1 over 1 plus x squared. Okay, but maybe let's make it even to be more general. So let's say you are deriving the inverse tan of g of x. So what you will actually get will be g prime of x on the numerator over 1 plus g of x all squared. So that is how our derivative of the inverse of tan works. So this means on the left hand side we are going to have dy dx equals, on the right hand side we are going to have 1 over 1 plus, we'll have hyperbolic tan of x all squared, then we'll multiply by, according to what I wrote here, which this here is just the chain rule. So let's make a note of that. So what I'm using here is chain rule. So when we apply that, it means I'm just going to multiply by the derivative of that hyperbolic tan. Okay, so already we know what the derivative of hyperbolic tan is, which means our expression dy dx has been simplified. The derivative of hyperbolic tan of x, we have found that it becomes hyperbolic sec square of x, and this will be divided by 1 plus, now this will be a square, so it will be hyperbolic tan square x. Now if you look at our denominator, we cannot really simplify it further, so what we are going to do is we just pause here, okay, and just call that our answer. So you can go ahead and try and simplify it further, but we'll just pause here. So what is the takeaway from this video? What you should understand is your hyperbolic functions, how when you derive them they work, what are the identities which are applicable when you're looking at hyperbolic trig functions, and very importantly you need to make sure you understand your chain rule. I hope this helps. It makes a lot of sense. Cheers.